As per the Pythagoras theorem, we know that in a right angled triangle, AC squared will be equal to AB square plus BC square. That is, the hypotenuse square will be equal to the sum of the squares of the remaining two sides. But let us now derive similar relationships for an acute angle triangle and a obtuse angle triangle here. So as you see, the first triangle ABC is an acute angle triangle, right? The angle B here is acute. It is clearly less than 90 degrees. It is not a right angle. It is lesser than the right angle. So we can say angle B is acute angle now, and also the remaining two angles are acute. So since all the three angles are acute, this can be considered as an acute angle triangle. And look at the second triangle here, ABC. Clearly angle B is greater than the right angle, right? It is more than 90 degrees. So angle B is obtuse, and hence the triangle becomes an obtuse angle triangle. So here angle B is obtuse angle. Now what happens in case of an acute angle triangle and an obtuse angle triangle? In a right angle triangle, we know that AC square equals to AB square plus BC square. That is, AC square, the hypotenuse square, will be equal to the sum of the squares of the remaining two sides. Now let us derive similar relationships for these two triangles. We have clearly understood that the side which is opposite to the largest angle will be largest side, and the side which is opposite to the smallest angle will be the smallest side. Now if the angle is 90 degrees, if angle B is exactly 90 degrees, what do we get? The opposite side, AC square equals to AB square plus BC square. But here the angle is less than 90 degrees, which means AC square should be less than AB square plus BC square. Likewise, in this case, the angle B is greater than 90 degrees. If it is exactly 90 degrees, what do we get? AC square equals to AB square plus BC square. But since the angle here is more than 90, the side also will be greater than what we have in a right angle triangle. Right? In a right angle triangle, AC square can be expressed as AB square plus BC square. But here, it will be AB square plus BC square plus a little more than that. Right? It should be more than AB square plus BC square. So let us derive those two relationships here. What we are going to do in the first case is drop a perpendicular from the vertex A on the opposite side, right? Let us drop a perpendicular. So let's say AD is the perpendicular here. It meets BC at the point D. So angle D here is 90 degrees. Now if you observe, ABC has got two right angle triangles. The first one is ADC, right? The first one is ADC. The second one here is ADB, right? There are two right angle triangles. Now let us look at the triangle ADC, right? In triangle ADC, what do we see? AC squared, right? This is a right angle triangle. So AC square will be equal to AD square plus DC square. AD square plus DC square, right? Now if you observe this side DC, right? The side DC here can be taken as BC minus BD. DC is nothing but the complete side BC, the complete base BC minus BD. So let us substitute that. So we get AC squared equals to AD square plus DC can be expressed as BC minus BD whole square. Let us now apply A minus B whole square expansion and see what do we get. So we get AD squared plus, this is BC squared plus BD squared minus 2BC into BD. Now if you look at the other part of the triangle here, the other right angle triangle, what is it? ADB, right? In the triangle ADB, we know that AB squared will be equal to AD square plus BD square. Yes or no? This is from the triangle ADB. In the triangle ADB, the hypotenuse is AB. So AB square can be taken as BD square plus AD square. And look at this relationship here. We have AD square plus BC square plus BD square minus 2BC into BD. Now here AD squared plus BD squared. AD square plus BD square can be replaced with AB square. Right? So what do we get? Finally AC square will be equal to AD square plus BD square is equal to AB square. AB squared plus BC squared minus 2BC into BD. So this is what we get in case of an acute angle triangle, right? AC square will be equal to AB square plus BC square minus 2BC into BD. If the angle is 90 degrees, if the angle B is 90 degrees, what happens? AC square will be equal to AB square plus BC square. We don't have this minus 2BC into BD. But since the angle is less than 90 degrees, this side AC square should be lesser than what we have in a Pythagoras theorem. So that lesser part here is minus 2BC into BD, right? So if we subtract this, we can get AC square there, right? So that's about an acute angle triangle. Let us now do a similar analysis for obtuse angle triangle. So what we are going to do here again is drop a perpendicular. Let's extend the side BC right? Extend the side BC and drop a perpendicular from the vertex A, such that it meets at the point D. Let's say this meeting point is D. And angle here again is 90 degrees, right? This is a right angle triangle. Now here again we see two right angle triangles. The first one is ADC, right? Triangle ADC. And the second right angle triangle is ADB, right? So two right angle triangles. Let us apply Pythagoras theorem. If you look at the first triangle, in the triangle ADC, right? What do we get in the triangle ADC? AC squared, the hypotenuse square, will be equal to perpendicular side, that is AD square plus DC square, right? AD square plus the base DC square. Again, the base DC, right? The complete base DC can be expressed as DB plus BC, right? It is DB plus BC. So let us replace it now. We get AC squared equals to AD squared plus DC is equal to DB plus BC square. So when we expand this using A plus B whole square formula, what do we get? BD square plus BC square plus 2 into BC into BD. Yes or no? DB or BD, right? So that square, A square plus B square plus 2A into B. Now let us look at the other triangle ADB here. Now from the triangle ADB, right? In triangle ADB, we know that AB square will be equal to AD square plus DB square. That's it. Now look at this equation here. AD square plus BD square, right? AD square plus BD square. AD square plus BD square can be replaced with AB square. So let us replace this part with AB square. So finally we get AC square equals to AD squared plus BC squared plus 2BC into BD. So this is the relationship for an obtuse angle triangle. And like we have discussed earlier, if this is a 90-degree angle, if this is a right angle, what happens? We get AC square equals to AB square plus BC square. But this is more than 90 degrees. So obviously the hypotenuse, not exactly the hypotenuse, the opposite side, right? The side opposite to angle B, which is obtuse angle, should be more than what happens in a right angle triangle. So in a right angle triangle, it is AB square plus BC square. But here it is a little more. What is that extra part? 2BC into BD. So these are two important relationships based on the application of Pythagoras theorem for an acute angle triangle and an obtuse angle triangle, right? So just remember these identities, that in an acute angle triangle, AC square will be equal to AB square plus BC square minus 2BC into BD. Whereas in an obtuse angle triangle, AC square will be equal to AB square plus BC square plus 2BC into BD.